All right, so a couple last examples here. Find the complete solution for the following system. So we're going to write the augmented matrix. So -3, -5, 36, 10, -1, 0, 7, 5, 1, 1, -10, -4. And so let's just start working on getting to row echelon form, although we're not going to worry about the ones. So I usually, honestly, I don't worry about the ones in leading entry if I'm going to be working with fractions. So you can't divide all of these by 3, and well, I mean you can, but you end up with fractions. So let's avoid fractions for now. And so let's just leave the first row alone. You can divide by -1 if you like, but that's not really necessary. And then we're going to multiply the second row by -3, add it to the first row. So we have 1 minus 3 times row 2. So that'll give us a 0, -5. That would be 36 minus 21. So that is 15. And 10 minus 15, so that gives us a -5. And then let's do for row 3, let's do 1 plus 3 times row 3. So that would give us a 0 here. -1 plus 3 gives us -2. 36 minus 30 gives us a 6. And then 10 minus 12 gives us a -2. And so now we will divide by the common factors for row 2 and row 3, just to make things easier. So we get 0. We'll divide by -5, so we get 1, -3, 1, and then divide this row by -2, and we get 1, -3, and 1. And so clearly these two are, row 2 and row 3 are the same, so we'll leave row 1 and row 2 alone. And then we will add row 2 plus row 3, and that will just zero out row 3. And so now we have a row of all zeros. That means we have infinitely many solutions. And so whenever we have infinitely many solutions, so we have a leading entry here, we have a leading entry here. So that leaves this column a free column. And so we say that z is a free variable. And so we could leave this as z, but on WebAssign, they want you to rename it as t. So when you have a free variable, meaning the third equation here was redundant. And so we really just have a system of 2 equations. And when you have a system of 2 equations with 3 variables, either there's no solution or there's infinitely many solutions. You cannot have one solution. So we're going to, z is a free variable, so we're just going to call it t. And then that means that we have y, so going to the second row, y minus 3, z equals 1. So y minus 3t equals 1. So we're just going to substitute the t in for z, and then let's just solve it for y. So we get 3t plus 1. So that is what y equals. And then we can do the same thing for the first row here. So -3. Actually, that's not what we should do. You can do that. But what we should do, let's keep going here. We can leave this the way it is. What we really want to do is let's get rid of this one and get this to reduced row echelon form. So let's get rid of the -5. So let's multiply row 2 by 5, add it to row 1. So 1 plus 5 times row 2. So we get -3. -5 plus 5 would be 0. 36 minus 15, that would give us a 21. And then 10 plus 5 would give us a 15. And then we can divide row 1 by 3, or -3. And see, this just makes things easier while we're finding the solution. You could keep going the way I was going before, but I think this way is a little bit better. So these have not changed. We didn't change row 2 and row 3 at all. So these are fine. And then this row now we have x plus 7z equals 5, or x plus 7t equals 5. And then let's bring the t over and get x by itself. And so that's what we have there. Actually, these are negatives. I messed up there. So let's back that up. Let's back that up. Forgot the negatives. Sorry about that. So this is why I had these written out beforehand, because I knew I'd make a mistake somewhere like that. So let's try this again. So x minus 7t equals -5, and then x equals 7t minus 5. So our ordered triple is 7t minus 5, comma, 3t plus 1, comma, t. And so what that means is we have infinitely many solutions. So you could pick any number for t, plug it in for these two, and get numbers for x and y. And that order triple would be a solution. So for instance, if t is 1, then t is 1, that would be a 2, that would be a 4, and a 1. And this would be a solution for this system of equations. Or you could plug in 2 for t, and then you get 14 minus 5, so that'd be 9. 6 plus 1, that'd be 7, and then 2. And so that would be another solution there. So infinitely many solutions, pick whatever number you want for t, and then that will dictate what x and y are, and then that gives you a solution. So, so this is the general solution for that one. Okay, and then the last example, I just put this one because it has 4 variables. We're not really learning anything new here, but this one has 4 variables and 3 equations. So, which tells us that we're either going to have no solution or infinitely many solutions. We actually end up with infinitely many here. So we have 1, 2, -3, -4, 10, 1, 3, -3, -4, 15, and then 2, 2, -6, -8, 10. All right, so let's work on reducing this. So we have 1, 2, -3, -4, 10. Let's just do row 1 minus row 2. So we have 0, 2 minus 3 is -1, 0, 0, 10 minus 15 is -5. And then let's do -2 times row 1 plus row 3. So we have 0, that'd be -4 plus 2, so -2. 6 minus 6 is 0. 8 minus 8 is 0. And then -20 plus 10 would be -10. And so we can see we could divide row 3 by 2, or -2, but let's we can see if we did that, we'd end up with the same as row 2. So actually row 3 is redundant. So let's just go ahead and put all zeros there. All right, so we have a leading entry there, leading entry here. So these two without leading entries are both free variables. So the z and the w are free variables. So we're going to say z is t, and we'll say w is s, or vice versa. I guess it doesn't matter which is which. And then we have y equals, actually, I'm going to use, let's see. But I want to use something besides s because we have a 5 in there. So just to keep things clear, let's use u. W equals u. Although it doesn't matter. You can pick whatever letter you want, I guess. Y equals 5 because it is not dependent on x and w, or z and w. And then the top row we have x plus 2y minus 3z minus 4w equals 10. Y is 5. Y is always 5 in this case. And then z is t, w is u. And let's just get x by itself. So the 10, 10 will cancel, and we can just bring these two over. So x is 3t plus 4u. And so now we have an ordered quadruple, I guess. So 3t plus 4u, y is 5, z is t, w is u, and then that is our ordered quadruple. And so you could pick any number for t, any number for u. Y is always 5, and then plug whatever you pick for t and whatever you pick for u, and you can get an x. So let's just say, for instance, let's say y is always 5, and let's just say we pick 2 for t or z, and then let's say we pick 3 for w. So then x would be 3 times 2 plus 4 times 3, so that'd be 6 plus 12, so that'd be 18. So this should be a solution for that system of equations. And I'll let you check, see if it works. I just kind of pick those numbers randomly. So if you have any questions, feel free to email me. This is a pretty dense section, so practice. Whenever you get stuck, just let me know.